Assalamu alaikum students. This is your instructor Muhammad Umar Khattak for the subject Project Management. This is our 22nd lecture and we'll be starting chapter 6. Today the topic of our discussion is Project Activity Planning. Initial project coordination and project plan. Thus far, we have dealt with initiating a project. Now we are ready to begin the process of planning the work of the project in such a way that it may be translated into hard work that actually leads to a successful completion of a project. There are several reasons why we must use considerable care when planning projects. The primary purpose of planning, of course, is to establish a set of directions in sufficient detail to tell the project team exactly what must be done, when it must be done, what resources will be required to produce the deliverables of the project successfully, and when each resources will be needed. The deliverables, scope, specifications, and objectives of the project are more than just mere descriptions of goods or services we promise to deliver to the client at quality level that will meet client expectation. The scope of a project also includes time and cost requirement to complete the project to the client's satisfaction. The plan must be designed in such a way that the project outcome also meets the objectives of the parent organization, as reflected by the project portfolio or other strategic selection processes used to appear the project. Because the plan is only an estimate of what and when things must be done to achieve the scope of objectives of the project, it is always carried out in an environment of uncertainty. Therefore, the plan must include allowances for risk and features that allow it to be adaptive, to be responsive to things that might disrupt it while it is being carried out. Once such disruption, scope creep, or the tendency of project objectives to be changed by the client, senior management, or individual project workers with little or no discussion with the other parties actively engaged in the work of the project is particularly common in software projects. A formal process to change the project scope will be discussed later on. In addition, the plan must also contain methods to ensure its integrity, which is to say, it must include means of controlling the work it prescribes. Finally, and quite apart from the specification on output required by the project itself, the plan must include any constraints on activities and inputs material prescribed by law and society. Among the many resources of outside constraint are the Food and Drug Administration, the Occupational Health and Safety Administration, various engineering society, the PMI, labor unions, and the standard practices of many different industries. It is crucial that the project objectives be clearly tied to the overall mission, goals, and strategy of the organization, such as might be reflected in the project portfolio process. Senior management should delineate the firm's intent in undertaking the project, outline the scope of the project, and describe how the project desired results reinforce the organization's goals. Without a clear beginning, project planning and later progress can be easily go astray. It is also vital that a senior manager call and be present at the project launch meeting, an initial coordinating meeting as a visible symbol of top management commitment to the project. The individual leading the launch meeting is first to define the scope of the project. The success of the project launch meeting is absolutely dependent on the existence of well-defined set of objectives. Unless all parties to the planning process have a clear understanding of precisely what is the project is expected to deliver, planning is sure to be inadequate or misguided. The precise nature of the scope statement depends on the nature of the project itself, and because of this, it reflects the fact that all projects are to some extent unique. Whatever the process, the outcome must be that technical scope is established, though perhaps not cast in concrete. Basic areas of performance responsibility are accepted by participants. Any tentative delivery dates or budgets set by the parent organization are clearly noted. A risk management group is created. Each individual unit accepting responsibility for a portion of the project should agree to deliver by the next project meeting a preliminary but detailed plan about how the responsibility will be accomplished. Such plans should contain descriptions of the required tasks and estimates of the budgets, labor and resources, and schedules. The project manager generally takes responsibility for gathering the necessary approvals and ensuring that any changes incorporated into the plan at higher levels are communicated to and approved by the units that have already signed off on the plan. Nothing is as sure to enrage functional unit managers as to find that they have been committed by someone else to alterations in their carefully considered plan without being informed. Violation of this procedure is considered a betrayal of trust. Several incidents of this kind occurred in a firm during a project to design a line of children's clothing. The anger at this change without communication was so great that the two chief designers resigned and took jobs with a competitor. The various parts of the plan, including the risk management plan and the scrutinized by the group and combined into a composite project plan. The composite plan, still not completely firm, is approved by each participating group, by the project manager, and then by senior organizational management. Each subsequent approval hardens the plan somewhat, and when senior management has endorsed it, any further changes in the project scope must be made by processing a formal change order. If the project is not large or complex, informal written memoranda can substitute for the change order. The main point is that no significant changes in the projects are made without written notice. Following top management's approval, the definition of significant depends on the specific situation and the people involved. Outside clients. When the project is to deliver a product service to an outside client, the fundamental planning process is unchanged except for the fact that the project scope cannot be altered without the client's permission. A common planning problem in these cases is that marketing has promised deliverables that engineering may not know how to produce on a schedule that manufacturing may be unable to meet. This sort of problem usually results when the various functional areas are not involved in the planning process at the time the original proposal is made to the potential client. We cannot overstate the importance of a carefully determined set of deliverables accepted by both project team and the client. Two objectives of such early participation by engineering and manufacturing are likely to be raised by marketing. First, the sales arms of the organization is trained to sell and is expected to be fully conversant with all technical aspects of the firm's product services. Further, salespeople are expected to be knowledgeable about the design and manufacturing lead times and schedules. On the other hand, it is widely assumed by marketing, with some justice on occasion, that manufacturing and design engineers do not understand sales techniques and will be argumentative and pessimistic about client needs in the presence of the client and generally not housebroken when customers are nearby. Second, it is expensive to involve so much technical talent so early in the sales process. Typically, prior to issuing a proposal, it can easily cost a firm more than $10,000 to send five technical specialists on a short trip to consider a potential client's needs, not including a charge for the first time lost by the specialist. The willingness to accept higher sales costs puts even more emphasis on the selection process. The rejoinder to such objection is simple. It is almost always cheaper, faster, and easier to do things right the first time than do than to redo them. When the product service is a complex system that must be installed in a large, more complex system, it is appropriate to treat the sale like a project, which deserves the same kind of planning. A great many firms that consistently operate in an atmosphere typified by design and manufacturing crisis have created their own panics. In fairness, it is appropriate to urge that anyone meeting customers face to face should receive some training in tactics of selling. A potential remedy for these problems is the use of multifunctional teams, also known in this context as concurrent engineering. This latter term, born in 1980s, has been applied to product service development, where typically a product design and its manufacturing process are developed simultaneously. Cross-functional groups are used to accomplish integration, and the voice of the customer is included in the product development process. Multifunctional teaming may also be applied to the software design and development process. In the software project, it is critically important to keep the customer involved in the process of developing software requirements from the start of the project. Clients often ask questions such as, while you are at it, can you fix it so the software will also do this? Software writers tend to focus on technical feasibility when dealing with these questions and not uncommonly fail to note the additional time and cost required. More will be said about multifunctional teaming later on. In an event, if multifunctional planning is not utilized, the risk management group should be informed. The group will have additional work to do. A special approach developed by the software industry for determining the project performance requirement is called requirement formulation. Although intended for use with outside client, it applies equally well for internal clients and for non-software projects. It involves having the project team work with the customers to elaborate through stories how they see the actor who will use the software project results interacting with it. The actor may be a person, group, or even other computer systems. The project team members work with the client to elaborate the stories and better understand how the software will interact and operate and all the various actions it needs to be able to take. The stories, often called use cases, are broken into small enough units that the project work can be clearly understood, its effort, the schedule, and cost determined, and any new technologies identified. Last, it is understood that the client stories will change over time. Some added, some changed, some dropped, and the team will have to stay in touch with the client to determine how their needs have changed. Project plan elements. Given the project plan, approval really amounts to a series of authorizations. The project manager is authorized to direct activities, spend money, request resources and personnel, and start the project on its way. Senior management's approval not only signals its willingness to fund and support the project but also notifies subunits in the organization that they may commit resources to the project. The process of developing the project plan varies from organization to organization, but any project plan must contain the following elements. Overview. This is a short summary of the objectives and scope of the project. It is directed to top management and contains a statement of the goals of the project, a brief explanation of the relationship to the firm's objectives, a description of the managerial structure that will be used for the project, and a list of all major milestones in the project schedule. Objective or scope. It contains a more detailed statement of the general goals noted in the overview section. The statement should include profit and competitive aims as well as technical goals. General approach. This section describes both managerial and technical approaches to work. The technical discussion describes the relationship of the project to available technologies. For example, it might note that this project is an extension of the work done by the company for an earlier project. The subsection on the managerial approach takes note of any deviation from routine procedure, for instance, the use of subcontractors for some parts of the work. Contractual aspects. This critical section of the plan includes a complete list and description of all reporting requirements, customer supplied, resources, liaison arrangements, advisory committees, project review and cancellation procedures, proprietary requirements, any specific management agreements, as well as the technical deliverables and their specification, delivery schedules, and a specific procedure for changing any of the above. Schedules. Each task is listed and the estimated time for each task should be obtained from those who will do the work. The projected baseline schedule is constructed from these inputs. The responsible person or department head should sign off on the final agreed on schedule. This section outlines the various schedules and lists all milestone events. Resources. Both capital and expense requirements are detailed by tasks, which make this project budget. One-time costs are separated from recurring project costs. Second, cost monitoring and cost control procedures should be described. In addition to the usual routine elements, the monitoring and control procedure must be designed to cover the special resource requirements for the project, such as special machines, test equipment, lab usage or construction, logistics, field facilities, and special materials. Personnel. This section lists the expected personnel requirements of the project, special skills, type of training needed, possible recruiting problems, legal or policy restrictions on workforce composition, and any other special requirements such as security clearance should be noted here. This reference to security includes the need to protect trade secrets and research targets from competitors, as well as the need to protect the national security. It is helpful to time phase personnel needs to the project schedule. This makes clear when the various types of contributors are needed and in what numbers. These projections are an important element of the budget, so the personnel, schedule, and resource section can be cross-checked with one another to ensure consistency. Risk management plans. This covers potential problems as well as potential lucky breaks that could affect the project. Sometimes it is difficult to convince planners to make serious attempt to anticipate potential difficulties or benefits. One or more issues such as subcontractors default, unexpected technical breakthroughs, strikes, hurricanes, new markets for new technology, tight deadlines and budgets, and sudden moves by a competitor are certain to occur. The only uncertainties are which, when, and their impact. In fact, the timing of these disasters and benefit is not random. There are times in the life of every project when progress depends on subcontractors, the weather, or timely technical success. Plans to deal with favorable or unfavorable contingencies should be developed early in the project's life. Evaluation methods. Every project should be evaluated against standards and by methods established at the project's inception, allowing for both the direct and ancillary goals of the project. This section contains a brief description of the procedure to be followed in monitoring, collecting, storing, and evaluating the history of the project. Project planning in action. Project plans are usually constructed by listing the sequence of activities required to carry the project from start to completion. This is not only a natural way to think about a project, it also helps the planner decide the necessary sequence of things, a necessary consideration for determining the project schedule and duration. Using a planning process oriented around the life cycle events common for software and hardware product developers, they divide the project into 9 segments: concept evaluation, requirement identification, design, implementation, test, integration, validation, customer test and evaluation, operations and maintenance. Each segment is made up of activities and milestones, significant events. As the project passes through each of the segment, it is subjected to a series of quality gates that must be successfully passed before proceeding to the next segment. This is the end of the lecture. Thank you.